Hello, today's video is Introduction to Logarithms. So, what in the world is a logarithm? A logarithm, or log as we are going to call it, is another way of writing exponents. So whenever we read this is logarithmic form, you read it like this: log base b of a equals x. And what that means in exponential form is that b to the x power equals a. So now I'm going to write those where you can see them a little differently. So if we have b to the x power equals a, and we write that as a log, the bases stay the same. So this is the base of an exponential, this is the base of a log. So the bases stay the same, and then these two switch. So you're going to have log base b of a is equal to x. All right, this is going to become easier the more we do it, but it's just memorization. Like, you just move stuff around. So let's look at some conversions here. We want to convert from log to exponent, or log to exponential. So log base 3 of 9 equals 2. So we decided the bases stay the same, and these two switch orders. So 3 squared equals 9. And that is a true statement. So you can probably be pretty sure that you switched them around correctly. But your answer is just 3 squared equals 9. We are just converting. We're not asking you to solve anything, nothing else. We just want to convert this from one version to another. So then for number 3, we're going to have 7 to the 0 power equals 1. The bases stay the same, and these two switch order. All right, number 5. Once again, the bases stay the same. That is not the base. Wow, Miss Schwartz, way to go. This is the base. The base stays the same. These two switch order. So 4 to the negative 2 power equals 1 over 16. And that is our answer. So now let's practice a few converting the other way. So we have log base 14 of 196 equals 2. Log base 12 of 12 equals 1. And then log base 2 of 1/8 equals negative 3. So all we're doing is just converting from one form to another. There's no evaluating happening right now. So as we talk about logarithms, something that we need to know about is called the common logarithm. And the reason we need to know about this is because your calculator has a log button, but that log button is base 10. It is not just any log. So the common logarithm is a logarithm with base 10, and it can be written without the base. So just like a square root is written with an invisible 2, and it's understood to be a 2, if you encounter something that says log of x, that's understood to be base 10. All right, so if you look at number 15, that's where we're going to see the logarithm, or the common log for the first time. But let's start with 13. So in order to evaluate this, so we want to figure out what this equals. So let's just say it's equal to x, because that's what we want to figure out. we can rewrite this as an exponential equation. So this would be 7 to the x power equals 49. And we can use you can figure out that 7 squared is equal to 49. Most of you will know that just by, just from previous knowledge. And if you don't know it for sure, you probably at least know well enough to test and see. So if you're not sure at all, then just start plugging numbers in for x. Does 1 work? Does 2 work? Does 3 work? Etc. But you should see that x should equal 2 because 7 squared equals 49. And so that means that log base 7 of 49 is equal to 2. So number 15, remember that when there's no base, it's assumed to be a 10. So 10 to what power equals 100? Once again, x equals 2. All right, now let's look at number 17. 2 to what power equals 64? And this power, I guess I should use an x because I've been using an x. So this might be one that you have to think about. So I would just start plugging things into my calculator. I know that 2 squared is 4, 2 to the third is 8. And so I'm just going to keep going and testing in my calculator until I find one that works. And you should find that when you raise 2 to the 6th power, that equals 64. So your answer is going to be 6. And finally, we have 9 to what power equals 1 over 81. Now, this might need a refresher. You might need a refresher on exponent rules. But the first thing I would suggest is ask yourself, if we just needed to get 9 to equal 81, what would our answer be? Well, it would be x equals 2. But this 81 is in the denominator. And if you remember, we talked about if we have negative exponents, then you get the reciprocal. So if we make this a negative, it will put that 9 squared in the bottom of the answer. So negative 2 is the value of log base 9 of 1 over 81. Okay, the last thing that I want to talk to you guys about before you go and work on these yourself is the change of base formula. Logarithms are not always easy to evaluate, and so sometimes you want to use the change of base formula. And you do this because your calculators, most likely, do not have anything except a base 10 log button. So when you have log base b of a, that is equal to log of a over log of b. And so remember, when we write log without a base, that is the common logarithm. So it means it's base 10. It's understood to be base 10. So we're going to rewrite number 21 as log of 64 divided by log of 16. And then we're just going to type that into our calculators. So I'm going to move us over to a calculator to look at how to type that in. Okay, so we have our calculator and we want to type in log of 64 divided by log of 16. You can use alpha y equals enter to create a fraction bar. And then the log button is to the left of the 7. It is right here. So we're going to hit log, and it gives us parentheses because on your calculator you need to make sure that it understands what's included in the logarithm. So we have log of 64 divided by log of 16. When we hit enter, it's going to tell us 1.5. I prefer fractions whenever they're clean, but either one is fine. So 1.5 or 3/2 is going to be your answer. Then for number 23, we are going to have log of 54 divided by log of 2. So I'm going to show you a different way to do this if your calculator does not do the alpha y equals enter trick. You can just type in log 54 end parentheses divided by log 2 end parentheses. And you're going to get a big long number. And if I try to turn it into a fraction, it's not going to work because it's not a good healthy fraction. So when we work with logarithms, we want to use 4 decimal points. So round to 4 decimal points. All right, so log base 2 of 54 equals 5.7549. And number 21 was equal to 3/2 or 1.5. All right, go ahead and finish the rest of this worksheet. Let me know if you have any questions. Have a great day.